This is the second video about titration calculations, and in this one we are going to look at how to calculate the volume for titration experiments. As in the last video, to carry out these calculations we need to know the equation to calculate concentration. So concentration equals the number of moles of solute divided by the volume of solution. As before, for the concentration there's no straightforward equation, but rather a series of 4 steps that we have to follow to carry out these calculations. You will find that the calculations for the volume, 3 out of the 4 steps are the same as we did for the concentration. It's only the last step that will be different. So we're going to look at a question and follow these 4 steps to answer it. 0.25 decimeter cube of 2 mole per decimeter cube sodium hydroxide was neutralized by 5 mole per decimeter cube sulfuric acid. Calculate the volume of sulfuric acid needed for the neutralization. Step 1, like last time, is find the mole ratio of acid and alkali, so in this case sulfuric acid and sodium hydroxide. To do this we need the balanced equation, which is H2SO4 for sulfuric acid plus 2NaOH for sodium hydroxide reacts to Na2SO4 sodium sulfate plus 2H2O, so water. The mole ratio that we have to find is for the sulfuric acid versus sodium hydroxide, and this time we need to look at the balancing numbers in front of the formulas, and this time we can see that there's actually a number 2 in front of the sodium hydroxide. There's no number in front of the sulfuric acid, and this means that the mole ratio is 1 to 2. So it means that for each sulfuric acid molecule there will be 2 sodium hydroxide molecules reacting here. So now we know the mole ratio. Step 2, calculate the number of moles for the solution of known volume and concentration. Still the same as we did in the first video, and the solution here of known volume and concentration is the sodium hydroxide, and the question it says that we have 0.25 decimeter cube and 2 mole per decimeter cube, so we know the volume and the concentration for the sodium hydroxide. To calculate the number of moles, again we have to rearrange the equation at the top. We can do this by timesing both sides with the volume of solution, and we will get the number of moles equals concentration times volume of solution. Now we just have to plug in the 2 numbers from the question here. So we get 2 mole per decimeter cube times 0.25 decimeter cube, and this gives us 0.5 mole of sodium hydroxide. Step 3, use the balanced equation to work out the number of moles of alkali that react. So again, similar to the last video, we already have the mole ratio, so we don't need the balanced equation anymore. The mole ratio for sulfuric acid to sodium hydroxide was 1 to 2. So this means that 1 mole of sulfuric acid reacts with 2 mole of sodium hydroxide. So we always just have half as much sulfuric acid reacting. So if we look at the 0.5 mole of sodium hydroxide that we have, it means we only need half as much sulfuric acid. So 0.25 mole sulfuric acid reacts with 0.5 mole of sodium hydroxide. So now we know the number of moles for sulfuric acid also, it's 0.25. Now we can move on to the last step, step 4, and this one is different from what we did before when we did the concentration in the other video. Calculate the volume of sulfuric acid needed. Again, now we have to rearrange the equation to be able to calculate the volume, and if we rearrange the equation at the top, we get volume of solution equals number of moles of solute divided by the concentration. The number of moles we have found out now, it's 0.25. The concentration for sulfuric acid is given in the question. It's 5 mole per decimeter cube. So now we just have to plug those numbers into our equation at the bottom. So we get 0.25 mole divided by 5 mole per decimeter cube. And this gives us a volume of 0.05 decimeter cube. Now, sometimes you might be asked to give your answer in centimeter cube. To do this, you just need to remember that to get from decimeter cube to centimeter cube, you need to times by 1000. So, to do this, we have to times the 0.05 by 1000, and this gives us 50 centimeter cube.